Welcome back for more trigonometry. In this video, we're going to be finding missing angles. And so the first thing we have to decide on is which angle it is that we're going to try to find. And like with finding a missing side, the key is to label the triangle correctly, pick the correct reference angle, and then just choose the correct trig ratio in order to solve the problem. So in this case, let's find angle M first. So let's circle that and make that our new reference angle. And so that means that we're going to label all the sides according to that reference. So this is opposite to that angle. This side here is always the hypotenuse. And that leaves behind this here as the adjacent. And so let's just decide now which two sides that we're going to use. And I mentioned this before in the other video, that you'll have to have only one thing that you don't know. So all the expressions end up being something like sine of a reference angle equals, g over x or something. And so you need to decide, okay, well, what sides are going to give me a situation where I only don't know one thing? So we don't know the reference angle, and so we need to know the two sides that we're using. Okay, so with that out of the way, let's see what we can do with this. And so the two sides that we already know are the opposite and the hypotenuse. So those are the two we're going to use, opposite and hypotenuse. And then this should be written down on our page already to help us decide which one of the primary trig ratios we're going to use. And so we don't know the adjacent, so we can't use either of the sides that use the adjacent. And so we're left with sine. Okay, so then you just write out the definition. So the sine of the reference angle M, okay, is equal to the opposite over the hypotenuse. And you can skip this step once you get the hang of things. So sine M is equal to the opposite, which is 24, divided by the hypotenuse, which is 46. And just a small note on this is that you have to be careful that both of these are in the same unit. Okay, so they are, so we're fine, but just be careful. Some of the problems you'll be dealing with, they'll probably try to slip you up by not having them in the same unit, and oftentimes in real life you'll have two measurements with different units. Okay, so let's figure out what 24 over 46 is. It's a decimal number. So just go here. So 24 over 46 is equal to 5217, 0.5217. Okay. 0.5217. I think I wrote down the wrong number. Nope, that's right. Okay, so that's the sine of M. So now, this is what the opposite divided by the hypotenuse is. Well, we don't want that. We want to know what angle always results in an opposite divided by hypotenuse for that angle of 0.5217. So it's like we have this table that has the sine of the angle and the angle. And so we know what the 0.5217 is, the opposite divided by the hypotenuse. And now we have to go this way to get the actual angle that gave us that ratio. And so the operation there is the inverse sine. So sine inverse of that. And so now that just becomes a button in your calculator. Oftentimes it's a shift or second function. So second function or shift, okay, depending on your calculator. And in my case, I think I can just write it out. So let's find out. So the sine inverse of 0.5217 is 31 degrees. Okay, it's okay to round it off to the nearest degree. That's what most questions are going to ask you to do. Okay, so 32 degrees. Okay, so let's just review what we did. We labeled the triangle. So we had the opposite and the hypotenuse. And then what we did was we wrote out the definition for sine, knowing that sine was the one with opposite and hypotenuse. We substituted in the values that we knew. We simplified to get the ratio in a decimal. Then we use the inverse sine to find the angle. There you go, there's your answer there. Now, we can also find angle K. And let's just figure out what angle K is by the easiest method possible. We know that all the angles add up to 180, but 90 degrees of it is used up for the right angle, and 32 degrees is used up for M. So altogether we get 90 degrees minus 32, which will be 58 degrees. So that's the easiest way, and that's the way you would practically do it. But what I'm going to do is I'm going to back up and I'm going to try to find that 52-degree angle using trigonometry and then confirm that they're both the same. So I'm just going to erase all this mess. You can go back in the video if you need to watch it again. We'll just get rid of everything and we're going to start this whole process over, but now we're going to try to find angle K. Now the key here is to know that because we're trying to find angle K, we need to relabel our triangle. Okay, so that's now our reference angle. This becomes the opposite. Now across from the right angle is always the hypotenuse, and the leftover side is always adjacent. And so now when we are trying to find out which sides we're going to use, we have to use two sides that we know. So now we know the adjacent and the hypotenuse. So adjacent hypotenuse, well, that's going to be cosine. So the cosine of our reference angle, which in this case now is K, so we're trying to find angle K, is equal to the adjacent over the hypotenuse. Like I said, you can skip right down to this if you're comfortable with that step up there. So the adjacent being 24 and the hypotenuse being 46. And again, we get 0.5217 is equal to cosine K. Okay, so now you might say, well, that looks a lot like what we had before, but the difference is we're going to do a different operation, right? We have to do the cosine inverse now of 0.5217. And so again, we'll jump over to our calculator. And of course, your calculator might look different. So the cosine inverse of 0.5217 is equal to 58, almost 59 degrees. So we'll call it 59 degrees this case when we round off properly. You notice it's a little bit different. That's because if you watched carefully before, we didn't actually get 32, we got 32 and something. And so the angles are different depending on how you round. So angle K then equals 59 degrees. Okay, so that should be enough, I think, to get you through almost any type of problem where you're given two sides and you have to find a missing angle. So good luck with those.